Cayley-Hamilton theorem. It says that if we have a square matrix A, and once we write the characteristic equation, we get some A lambda square B lambda plus C equals 0. And this theorem says that this A satisfies the lambda, which means that this can be written in place of the lambda. Something like this: A into A square plus B into A plus C equals 0. And fundamentally, this is used in two places. The first one, finding the inverse. The second one, finding the higher power of matrix, something like A power 5 or maybe A power 4 and so on. First, let's learn how do you find the inverse using the Cayley-Hamilton theorem. Here we have a question. Find the inverse of A equals 6226. Let's use Cayley-Hamilton theorem, for which I'll write the characteristic equation. We get the equation as lambda square minus 12 lambda plus 32 equals 0. And we know that the matrix A satisfies this equation. Therefore, I can write this as A square minus 12A plus 32I equals 0. Because 32 is a scalar, I am augmenting it with a identity matrix. If I subject the I can write it as I equals, we take everything on the other side, we get it as 1 by 32 into 12A minus A square. For this, let me multiply A inverse on both sides. This equation becomes A inverse equals 1 by 32 A inverse into A minus A inverse into A square. This is 1 by 32 12I minus A. Let me write this over here. Once we substitute the A, we get it as 1 by 32, which becomes 1 by 32, 6 minus 2 and 6. That's how we find the inverse for a matrix using the Cayley-Hamilton theorem. Now let's learn how do you find the higher power of matrices. Here is a question asked in GATE 2012 EC. Given that A is minus 5, minus 3, 2 and 0, the value of A cube is. To find this, let's write the characteristic equation. So we have lambda square plus 5 lambda plus 6 equals 0. And A satisfies this particular equation. So we can write this as A square plus 5A plus 6 equals 0. From this I can write A square as minus 5A minus 6. Now if I multiply A on both sides, we get A cube equals minus 5A square minus 6A. But A square we already know, so let's substitute this over here. We get 25A plus 30I minus 6A. That is 19A plus 30I. Therefore the answer is B.